Okay, so now it's got time to go through paper 2, the multiple choice extended option for chemistry. This is IGCSE from Cambridge International Examinations, CIE. This is May-June 2018 and the code is 0620/21. All right, let's get started.
Let the games begin.
Question 1. A student investigated the diffusion of ammonia gas, NH3, and hydrogen chloride gas, HCl. 2 sets of apparatus were set up as shown at room temperature and pressure. So we have a test tube, the source of the gas is over this side, and we have damp litmus paper, and we're just waiting till the gas diffuses its way over to the litmus paper, and it should change color. Okay, so we have damp red litmus paper in the first one, and it will turn blue. So damp red litmus paper in apparatus 1 changed color after 30 seconds because ammonia gas is alkali, and it will change it to blue. Okay, how long does it take for the damp blue litmus paper to change color in apparatus 2? Okay, so it'll take 30 seconds, which is the same amount of time as apparatus 1. Does it take longer, shorter, or will it not change color? Now, if you look at this, for D, the blue litmus paper would not change color. Hydrogen chloride gas, well, that's acidic. That's an acidic gas. And when that goes over this way, the color for acidic is red. So it will change the blue litmus paper red. So that's not an option. D is not an option. Now, to answer this question, what we really need to look at is the actual molecules. Now, we need to find the molecular mass. What is the molecular mass of each one of these? So, for ammonia, we have an N. The mass of nitrogen is 14, and H3 is 1. So N, 14 plus 3 ones, that's 17. And for hydrogen chloride gas, we have 1H, so 1 plus 35.5, that's 36.5. So the molecular mass of NH3, ammonia, is 17, and hydrogen chloride gas, that's 36.5. All right, so this took 30 seconds at a molecular mass of 17. HCl, is that heavier, lighter? Well, clearly it's heavier than the NH3, which means it takes longer for those big clunky molecules to bounce their way all the way to the litmus paper. They're just big and heavy in comparison. Okay, so if it takes longer, the one that takes longer, that would be 64 seconds. And if you look at this, 36.5 is just over double 17, so it makes sense it would take just over double the amount of time. So that one makes sense. Question 2. Chromatography is a technique used to separate colored dyes. Which dye has an RF value of 0.7? So remember, RF value equals the distance of the color, the dye, solute, over the solvent. Okay? So you don't really need to have a perfect ruler for this. Because you're figuring which one is closest to 0.7, they're pretty spread out. So we can make up a bit of a scale. Okay, so what I've done is I've just created just an arbitrary scale. You can use your ruler and do it more accurately. I just did this because it's more easy on the computer to show you what it looks like. Remember, so we have the solute over the solvent, the dye over the solvent. Okay, so A, it looks like we've gone up 1, 2, 3. Going to the top, basically how far is the maximum it's gone. So that's 3 out of 10 arbitrary units that I've just made up, and I just did it by eye, so it doesn't have to be perfect. Okay, if we look at point B, that looks like it's gone up 9 out of 10 arbitrary units. So this is 0.3, this is 0.9. For C, it looks like it's gone up 5 out of 10 arbitrary units, and for D, looks like it's gone up 7 out of 10 arbitrary units. So this is 0.5 and this is 0.7. So the answer is D. All right. Question 3. Which piece of apparatus is used to measure exactly 26.3 centimeters cubed of a liquid? Okay, so A, this is a burette. And a burette is a very good option for measuring exactly 26.3 centimeters cubed of liquid. That's really what you'd use. It's a nice narrow tube. Okay, and you can use their little open closed stopcock thing there to be very careful with it. B, it could be a syringe or it could be a gas syringe. Well, with a syringe, yes, you can measure liquids. It's hard to tell what the scale is, but if you look at it, these little gradations are much further apart than they are here on an A. Okay, so that means that you can't measure it exactly. Okay, C is a pipette, and pipettes often don't measure as high as 26.3 centimeters cubed. That's a pretty big measurement for a pipette. And D is a graduated cylinder, or a measuring cylinder, and that is used to measure things much more quickly, but it's less accurate. The meniscus is much more visible, and these gradations are actually larger because the diameter of the tube is wider. Okay, so the answer is A. 4. The lead in a pencil is made of a mixture of graphite and clay. Okay, so it's not actually lead. It used to be made of lead, but now it's made of graphite and clay. When the percentage of graphite is increased, the pencil slides across the paper more easily. Which statement explains this observation? A. Graphite has a high melting point. That has nothing to do with sliding across the paper. B. Graphite is a form of carbon. Yes, but I don't see how sliding across the paper shows that it's a form of carbon. That's definitely not a test for carbon. Graphite is a lubricant. Yes, a lubricant helps things move across a surface. So that sounds good. And graphite is a non-metal. Yes, it's carbon, is a form of carbon, but I don't see how sliding across the paper is going to show that it's a non-metal. All right, so the answer is C. Question 5. Chlorine exists as two common isotopes, Cl35 and Cl37. Information about these two isotopes is shown. So we have the number of protons, the number of neutrons, and the number of electron shells. Which statement explains why the two isotopes are of the same element? Okay, so both have the same number of electron shells. No, that doesn't explain that. There's a lot of things that have the same number of electron shells. Everything in the same period has the same number of electron shells. It doesn't make them the same element. They both have the same number of protons. Well, that is really the definition of being of the same element, so yes. They both have 7 outer shell electrons. Nope, the outer shell electrons, well, they'll change whether it becomes charged or not, so that has nothing to do with whether they're the same element. And Cl37 has 2 more neutrons than Cl35. Well, yes, but that does not explain why they're of the same element. All right. Question 6. Which substance is not a macromolecule? Remember, macro means big and molecule means molecule. Which is not a big molecule, one that can get huge. Diamond, that can be a big, big molecule. Graphite, same thing, big, big molecule. Silicon 4 oxide, big, big molecule. And sulfur, no, that's a small molecule. It's not a big molecule. Question 7. Copper is a metallic element. Which statements about copper are correct? So it's not just which statements about metallic elements, it's specifically about copper. 1. Copper is malleable because layers of ions are in fixed positions and cannot move. Malleable means it can move, and it's easy to bend into different shapes, really. So saying it cannot move does not really make sense. 2. The structure of copper consists of negative ions in a lattice. Well, they're not in a lattice. They can move from place to place depending on if there's a charge put in one place, one area or another area. It's a sea of electrons. It's not a lattice. 3. Copper conducts electricity because electrons can move through the metal. That is definitely true. And electrons hold copper ions together in a lattice by electrostatic attraction. Yes, the copper ions, the Cu2+, they're held together in a lattice, but the electrons are not in a lattice. So yes, that's also true. So the answer here is D, 3 and 4 only. Okay, so the electrons are not in a lattice, but the protons, the copper ions, not just the protons, the nucleus, that's in a lattice. Question 8. The equation for the combustion of ethane is shown. So we have 2C2H6 plus 7O2 produces 4CO2 plus 6H2O. Which volume of carbon dioxide at room temperature and pressure is formed when 0.5 moles of ethane burn? Okay, so we have 0.5 moles of ethane. Okay, if we have 0.5 moles of ethane, we want to find the volume of carbon dioxide. So that we have double the number of moles formed, so we should have 1 mole of carbon dioxide formed. Okay, 1 mole of carbon dioxide, so you keep in mind CO2 is a gas. At room temperature and pressure, 1 mole takes up 24 decimeters cubed. That's just the molar gas volume. That's one of those numbers you need to know. There we go. The answer is B. Question 9. A solution of ethanoic acid, CH3COOH, has a concentration of 2 moles per decimeters cubed. Which statement about this solution is correct? Okay, so we have our formula. Moles equals mass over molecular mass. Okay, and we have concentration equals moles divided by volume. I should probably read the options before I put those down. A. 20 grams of ethanoic acid is dissolved in 10 centimeters cubed of water. B. 30 grams is dissolved in 250 centimeters cubed of water. C. 60 grams of ethanoic acid is dissolved in 1 decimeter cubed of water. And 120 grams of ethanoic acid is dissolved in 2 decimeters cubed of water. Okay, so to answer this question, we need to remember a couple of formulas. So first of all, we have to figure out the number of moles that are in the solution. So this question is giving us a concentration, okay? And it's giving us a few possible scenarios, to see which one results in that concentration. So remember, concentration of a liquid, the formula for this one, that equals moles over the volume, okay? Now, we're not given moles, we're given grams. So moles equals mass over molecular mass. All right, molecular mass of CH3COOH. So we have molecular mass of carbon is 12 plus 1 plus 12 plus 16 plus 16 plus 1. Okay, so the molecular mass of CH3COOH is 60. All right, so if we're looking at this, first of all, we have to figure out how many moles are in these number of grams, and then we have to divide it by the concentration we're given in decimeters cubed. Because sometimes some of these are in centimeters cubed, some of these are in decimeters cubed. That's the trick there as well. All right, so first of all, moles equals mass over molar mass. We have 20 grams divided by 60 grams per mole. And we divide that by, this is 10 centimeters cubed, that is 0.01 decimeters cubed. If you plug that into your calculator, you will get 33 moles per decimeter cubed. Okay, that is clearly not the answer. Next one, 30 divided by 60. Divided that by 250 centimeters cubed of water, which is 0.250 decimeters cubed. That equals 2. That looks right. Moles per decimeter cubed. So I'm going to say it's B. Just double check the other answers. We have 60 divided by 60 divided by 1 decimeter cubed divided by 1. So 60 divided, that's 1 divided by 1. That equals 1 mole per decimeter cubed. That's not the answer. And the final one, 120 grams. 120 grams divided by 60 grams per mole. divided by 2 decimeters cubed, well, that equals 1 moles per decimeter cubed. So the only one that works out is B, and you should only have one that works out, or else you have the wrong approach. All right, so let's continue. Question 10. Aqueous copper 2 sulfate is electrolyzed using copper electrodes. Which statement is correct? Okay, so is it a reduction reaction at the positive electrode? Is there a blue color of solution becomes darker? Concentration of copper ions in the solution decreases, or the mass of the negative electrode increases? Well, to do this, we have to remember about electrolysis, and I always remember when you see an electrolysis question, you should panic. The only time you should panic on a science exam. So positive anode, negative is cathode. Okay, now at the positive anode, so let's quickly draw this out very roughly. Okay, we have our electrolyte in here. We have 2 electrodes. Okay, and they're connected, and one of them's negative, one of them's positive. Okay, in the solution, it's copper 2 sulfate, so we have some Cu2 plus, we have some SO4 2 minus. Okay, and they're using copper electrodes. Cu. You can't really read that very well, but they're copper electrodes. Okay, so what's happening? So the plus will move towards the minus. The minus will move towards the plus. All right, and then the extra electrons on the SO4 2 minus will travel around the circuit and make this one negative. Continue to make it negative. Okay, that's pretty much it. And so this is the copper solid. It will come out of solution. Okay, so looking at A, a reduction reaction occurs at the positive electrode. So positive anode. So if you remember oil rig, we have our oil rig. That's a G. Our oil rig. Reduction is gain of electrons. So which one of these are at the positive electrode? So does SO4 gain electrons? No, it loses the electrons. So that is not the answer. Okay, we're not talking about the electrode. It's the ions in the solution that are gaining or losing. Okay, the blue color of the solution becomes darker. Well, no, because the Cu2 plus is coming out of solution and depositing on the outside of the copper electrode. Okay, so the concentration of copper ions in the solution decreases. Well, no, because it's being replaced by some copper ions that are coming off of this electrode, the positive electrode. Okay, and the mass of the negative electrode increases. Yes, the mass of the negative electrode increases because the copper is depositing on it. So yes, the answer is D. There we go. Question 11. Dilute sulfuric acid is electrolyzed using inert electrodes. Inert meaning it doesn't react with what's reacting, what's in the solution. What are the ionic half equations for the reactions that take place at each electrode? So when we have dilute sulfuric acid, we have in our solution, we'll have some H plus from the H2SO4. We have SO4 2 minus. We also have, this is dilute, so we have some H plus and OH minus. It's an H minus from the water. OH minus. Okay, now basically the H pluses and the OH minuses outcompete the SO4 2 minuses at the electrodes. That's pretty much what happens, making it simple. All right, so what is the reaction that happens? Okay, first of all, at the positive electrode, remember, if we look at our electrodes, we have our plus, we have our minus, doesn't matter which one's which. We have some pluses, some minuses. The minus will go to the plus, and the plus will go to the minus. Okay? At the positive electrode, we will have minuses, we have the negatives, we will have the anions going towards the negative. So that is C or D. Okay, and it's the same on the other side. So we'll have at the negative electrode, we'll have the cations going to it. So it's one of those two options. Now, what happens? Is it that the electrons are released, or is it that it forms water? Okay, because for the positive electrode. Well, what happens here is the negative ions go, as I said, go towards the positive electrode, and the electrons then move through the circuit to make this a negative, to make the negative electrode negative. So the electrons move. So that means that these electrons have to be released. All right, so the answer has to be C. And at the positive electrode, the H's have to gain the electrons that were released at the positive electrode. So the answer is C. It doesn't form water. It basically, these reactions allow the electrons to move around the circuit. All right. Question 12. Plant cells use energy from sunlight for photosynthesis. Which row describes and explains the energy change that occurs? Okay, so photosynthesis. Is photosynthesis an endothermic or exothermic reaction? Well, it's an endothermic. It's basically taking in energy. Okay, it's taking in energy. And what is the definition of an endothermic reaction? Is it less energy is released making bonds than is absorbed to break bonds? Or more energy is released making bonds and is absorbed to break bonds? Okay, so remember, bond breaking, now that is an endothermic process. Okay, when you break the bonds, it means it takes energy to do that. So if it's an endothermic reaction, it has to have more energy absorbed to break the bonds. So the answer has to be A. All right. Question 13. Hydrogen bromide decomposes to form hydrogen and bromine. The equation is shown. So we have 2HBr, which is a gas, produces H2, which is a gas, and Br2, which is a gas. The bond energies are shown in the table. The reaction is endothermic. Endothermic means that it's absorbed more energy from the surroundings, so the surroundings feel colder, but the reactants and products, they have more energy. It's gained energy. So that means, what is the energy change for the reaction? It's going to be either A or B, one of those two. All right. So let's look at this. So we have, whenever you do these, you have to break it down. We have 2 times the HBr, okay? And the HBr reaction, that's 366. So 2 times that, that's 732 kilojoules per mole, okay? Now we have 1 H2 bond, okay? And that equals, as it says here, 436. Okay, and we have 1 Br2 bond, so that is Br, and that is 193. Now, if we remember the reaction, the total energy change, that's bonds broken minus the bonds formed. Okay, so here, that's the dividing line. So they had to break the 2 HBRs. So that's 732 minus 436 plus 193. So the answer to that is plus 103, just putting it into your calculator. So plus 103, well, that is the answer of B. And it makes sense because you're expecting it to be positive. There we go. Question 14. Which row describes the effects of increasing both the concentration and the temperature on the collisions between the reacting particles? Okay, so if you increase the concentration, do you get more collisions per second? Well, yes, you get more collisions per second. Okay, do you get more collisions per second and more collisions with sufficient energy to react? Well, the concentration has nothing to do with how much energy they have. It just has something to do with how many there are. So it doesn't have those two. It's only the more collisions per second. Okay, if you increase the temperature, do you get more collisions per second? Yes, you do, but it's not only. You also get, they have more energy. If you have increasing temperature, they have more energy. So more of the collisions will have sufficient energy to react. So it's one of those two. So clearly the answer is C. Question 15. The formation of sulfur trioxide is a reversible reaction. The equation is shown. So we have 2 SO2 gas plus O2 gas produces 2 SO3 gas in a reversible reaction. The forward reaction is exothermic. Which conditions produce the highest equilibrium yield of sulfur trioxide? Okay, for pressure. Now, as each one of these are gases, changing the pressure has only to do with the number of moles. So on the reactant side, how many moles do we have? We have 3 moles. On the product side, we only have 2 moles. So if you increase the pressure, it will go towards the product side. So it has to be either A or B. All right, now we are looking at the temperature. So the forward reaction is exothermic. It gives off energy. When you increase the temperature, what happens is it tries to reverse whatever you're doing to it. So if you increase the temperature and it's an exothermic reaction, it will make the reaction go in the reverse reaction. Okay, so if we want to increase the yield of the products, we need to decrease the temperature. So it does exactly the opposite of what you think it should, what it says it does. It tries to balance things out. So the answer here is B. It tries to do exactly the opposite. Question 16. Chlorine displaces iodide ions from potassium iodide. So we have Cl2 plus 2I minus produces I2 plus 2Cl minus. What is the oxidizing agent? Okay, the oxidizing agent, the agent of oxidation is the one that is being reduced. So the one that's causing oxidation because it itself is being reduced. So remember oil rig. Okay, oxidation is loss, reduction is gain. So reduction is gain. Which one is gaining electrons? Is it the iodide? No, it already has electrons, it's losing them. So it has to be the chlorine. You never look at the product side when you're figuring out which is the oxidizing agent, which is the reducing agent, which one's being oxidized, which one's being reduced. Okay, so this means it is the chlorine, not the chloride. Question 17. Which statement about oxides is correct? Okay, so A, is a solution of magnesium oxide, does it have a pH of less than pH 7? Okay, so magnesium oxide is a basic oxide. If it's a basic oxide, that means it's going to have a pH of more than pH 7. It's going to be basic, so no. A solution of sulfur dioxide has a pH greater than pH 7. So sulfur dioxide forms sulfuric acid when it's dissolved in water. So it's going to have a pH less than pH 7. It's going to be acidic. Magnesium oxide reacts with nitric acid to make a salt. Okay, we have our magnesium oxide is a basic oxide again. So we have our alkali plus our nitric acid produces salt plus water, our basic neutralization reaction. So C looks like it's the answer. And sulfur dioxide reacts with hydrochloric acid to make a salt. Well, acid plus alkali produces salted water, not acid plus acid. So no. Okay, question 18. Which solution has the lowest pH? Okay, so 0.1 moles per decimeter cubed of a variety of things. Which one is most acidic? Ammonia, well, ammonia is alkali, so that's out. Okay, that's an easy one. The rest of these are all acidic. Now, which one is easiest for the H plus to be removed? That's how you know it has the lowest pH. Which one will lose the H plus more easily? So, ethanoic acid, remember your monkeys eat peeled bananas, methane, ethane, propane, butane. So ethanoic acid has 2 carbons. So we have C, C, O, OH, and these are all H's. This is ethanoic acid. Okay, so it loses this H when it dissolves in water. Now, this H is being held on by a pretty big molecule here. The O as well. It's being held on by all of that. It's held in much more tightly. Okay. Lithium hydroxide. Hydroxides are alkali. They're also out. That's easy. Okay. Nitric acid, on the other hand, we have HNO3. Okay. The NO3 is much smaller than this molecule, so basically it doesn't hold it as tightly. It can't hold it as tightly if there's not as much there. Okay, so H is much more easily lost. Okay, so the answer is D. So same concentration, but the H is more easily lost into the solution, so that means it's more acidic. Question 19. A student mixes silver nitrate and barium chloride to form a white precipitate of silver chloride. The equation is shown. Okay, so silver chloride, it said that's a precipitate, so that one's a solid. Okay, so these are solutions. Student mixes silver nitrate and barium chloride. This is a precipitation reaction, so these would have to be aqueous. These would be aqueous. And this would also be aqueous. All right, because the precipitate is silver chloride. That's the only thing that's going to be a solid. Okay, so basically, which row describes the solubility of the salts? We need to figure out which one is a solid. Okay, which one is insoluble? That would be the solid. Okay, everything else is aqueous because it's soluble. All right, so silver chloride, that looks like it's the answer. Silver nitrate, barium chloride, and barium nitrate. Yeah, that works. So the answer here has to be C. All right. 20. Which methods are suitable for preparing both zinc sulfate and copper 2 sulfate? Okay, so 3 ways of preparing salts. Which ones can they use for both of those salts? Okay, so 1. Can you react the metal oxide with warm dilute aqueous sulfuric acid? Yes. Yes. They will both react with warm dilute aqueous sulfuric acid to form the salt. Can you react the metal with dilute aqueous sulfuric acid? You can with zinc sulfate, but copper 2 sulfate, copper metal, just a plain metal, is very unreactive. If you drop some dilute aqueous sulfuric acid on to copper sulfate, to copper, nothing will happen. So the answer is no for that one. Okay, you will for zinc. If you put the dilute aqueous sulfuric acid on zinc, it will bubble and you'll form the salt, and that's exactly what you'd expect. But but copper is a lot less reactive. Can you react the metal carbonate with dilute aqueous sulfuric acid? And yes, you can, and it forms carbon dioxide. So the answer here is C. 1 and 3 are the only options. Question 21. Which element is in the same period of the periodic table as silicon? Okay, let's look at the periodic table. Okay, so we are looking for silicon. So we have groups and we have periods. So the groups are, here we have group 1, we have group 2, we have group 3, 4, 5, 6, 7, 8 in the transition elements. Okay, so those are the groups. The periods are the ones that move horizontally. So the elements that are in the same period as silicon, well, they are anything on this whole line here. Anything on this line whatsoever. So the options we have are germanium. Well, germanium is here. That is clearly not on the same period. Do we have scandium? Scandium is right here. Nope, not one of the options. We have sodium. Sodium right here. Yes, that is definitely on the same period. And just to be clear, here we have strontium here, and that's a no as well. So germanium is in the same group, sodium is in the same period, and that's what you're being asked for. So the answer here is sodium. Question 21. Okay. Question 22. Which statement about the halogens is correct? Okay, remember the halogens. They're group 7. So a sample of bromine reacts with potassium chloride solution. Bromine reacts with potassium iodide solution. The chlorine has a higher density than a sample of bromine, and a sample of chlorine is a darker color than the sample of bromine. So remember, we have chlorine is more reactive than bromine, which is more reactive than iodine. Okay, so when you say a sample of bromine reacts with potassium chloride, it would mean that the bromine would have to be stronger than the chloride so that it kicks the chloride out of the way and becomes potassium bromide. So bromine is stronger than chloride. No, that doesn't work. Bromine reacts with potassium iodide. Well, yeah, that sounds like it's the answer. I'm going to circle that one because bromine is more reactive than iodine. And a sample of chlorine has a higher density than a sample of bromine. Note, chlorine is a gas and bromine is a liquid that turns to a gas easily, but it is not as, but chlorine is always a gas. Well, it's not always a gas. When you get to the higher pressures or lower temperatures, it's not, but room temperature and pressure it is. A sample of chlorine is a darker color than a sample of bromine. No, bromine is a dark orangey yellow color. So the answer is B. 23. Which row shows the catalytic activity of transition elements and their compounds? So we have transition elements are well known to be good catalysts. So the catalytic activity of transition elements, yes, that's good. They're known to be good catalysts. What about the compounds of transition elements? Well, they're also known to be good catalysts. I don't think you were probably ever told that it's only the pure element that is a good catalyst. So it is A. Question 24. The following statements are made about the metals copper, iron, magnesium, and zinc. All right, so which ones are true? Which statements are correct? Are their oxides acidic? Well, magnesium is an alkali earth metal, which means its oxide is basic, as a basic oxide. Do they all conduct electricity in the solid state? Yes. Yes, they all conduct electricity in the solid state. Do they all have high melting points? Well, high is a relative term, but yes, they do. They're solids at room temperature, so they're not liquids or gases, which means they have a high melting point, really. Do they all react with dilute acids to form hydrogen? The key there is dilute. In strong acid, yes. Copper will react with a strong acid. A warm acid, yes, but not dilute acids. So copper is quite unreactive. So it's 2 and 3 only. C. All right. Question 25. Silver is a less reactive metal than cadmium. Cadmium is a less reactive metal than barium. Which statement is correct? Okay, so we have the most reactive is barium. Then we have cadmium. And then we have silver. Okay, so cadmium is less reactive than barium. Yep, and silver is less reactive than cadmium. Yes. Okay, so which statement is correct? A. Barium does not react when heated with silver oxide. Okay, so remember, it would react if barium is stronger than silver. Okay, so is barium stronger than silver? Yes. So it does react when it's heated with silver oxide. Cadmium displaces barium from a solution of barium chloride. That means cadmium has to be stronger than barium. Is cadmium stronger than barium? No. Cadmium displaces silver from a solution of silver nitrate. That means that cadmium has to be stronger than silver. Well, yes, it is. And cadmium reacts when heated with barium oxide. Is cadmium stronger than barium? No. So the answer here is C. Next. Question 26. Aluminium metal is extracted from aluminium oxide using electrolysis. Which statement about the extraction process is not correct? Always look for that not word there when it is. Okay, so is a large amount of electricity required? Yes, it does require a large amount of electricity. Do you need molten cryolite to dissolve the aluminium oxide? Yes, you do. And oxygen gas is released which reacts to form carbon dioxide? Yes, because they have carbon electrodes. That's why it reacts to form carbon dioxide. And the negative electrodes burn away and have to be replaced. Well, yeah, they don't burn away. There's no need for it to burn away. There's no flames. Burning is a reaction in itself. So no, the answer is D. Question 27. Which statement explains why aluminium is used in the manufacture of aircraft? Is it because it conducts heat well? I don't see why that would be useful in the manufacturing of aircraft. Is it because it has a low density? Well, that's kind of useful. You want something to fly. You don't want it to be very heavy. Is it because it's a good conductor of electricity? I can't see how that would be useful for creating an airplane. And is it because it is easy to recycle? You don't really want to recycle your airplanes very often, so no. So B. The answer is B. Question 28. Dry air is passed over hot copper until all the oxygen has reacted. Okay, so we have our copper in this middle tube, and it's heated, and we have dry air, and it's pushed across so it reacts with the copper, and all of the oxygen that's in the air is used up. The volume of gas at the end of the reaction is 120 centimeters cubed. What is the starting volume of dry air? So basically they're saying how much oxygen is in dry air. Okay, obviously wet air, it could be anything because you get the humidity can change dramatically in different areas. But if you have dry air, what is the percentage of oxygen that you have? Okay, you have about 21% oxygen in dry air. Okay, that means 79% of dry air is everything else. All the other gases that are not oxygen. You have nitrogen, argon, a bunch of other things. Okay, so what we have to do, we end off with 120 centimeters cubed, and we want to know basically how much do we start off with when 21% of whatever we started off with was oxygen. So the equation we use for this, we have 120 centimeters cubed, and we divide it by 79%. Okay? Because that 79% is everything else. That 120 centimeters cubed is everything else. Okay, so divide it by 0.79. Okay, and that equals 151.9 centimeters cubed. Okay, and 151.9, well, that's 152 centimeters cubed because it's not exactly 21%. There are decimal places in there. Question 29. A steel bicycle which had been left outdoors for several months was starting to rust. We've all seen this before. What would not reduce the rate of corrosion? Okay, so you don't want the bicycle to react anymore, to corrode anymore. which one of these is something you would not do? Okay, so not. Which one would not reduce the rate of corrosion? So removing the rust and the paint and painting the bicycle. Yeah, if you remove the rust and then you paint the bicycle, you are creating a nice barrier between the steel and the air and water. So that will make it so that it reduces the rate of corrosion. If you remove the rust and store the bicycle in a dry shed, yeah, that's a good idea. It's always a good idea to store it in a dry place. Remove the rust and wipe the bicycle with a clean, damp cloth. Why a damp cloth? Because with rust, that needs water to react. So damp is not something you would normally try and expose a surface that is prone to rusting. Okay? Remove the dust and wipe the bicycle with an oily cloth. That would work because oil creates a barrier between the water and the air and the steel. So you're absolutely fine. So C is the one that would not reduce the rate of corrosion. Question 30. Which statements about water are correct? Household water contains dissolved salts. Yes. When you boil your kettle, you get salts that come out of the water. You wash them off by rinsing them with vinegar, and that works. But obviously some areas get more than others. But there are dissolved salts in household water. Water for household use is filtered to remove soluble impurities. They're soluble impurities. I don't see how filtering can actually help remove soluble impurities. You can't run salt water through filter paper and just get out plain water. There'll still be salt water on the other side. So that will not be very useful. Water is treated with chlorine to kill bacteria. Yeah, you don't want your household water to have bacteria in. Chlorine evaporates over a relatively short time, so that's okay. Water is used in industry for cooling. Yeah, it is. So it's 1, 3, and 4 only. That's C. That's the answer. Question 31. Ammonia is manufactured by reacting hydrogen with nitrogen in the Haber process. All right. Which row describes the sources of hydrogen and nitrogen and the conditions used in the manufacture of ammonia in the Haber process? Well, you had to learn this one for your paper 3 or 4, I'm sure. You just need to know the conditions. So let's look at these. Okay, so the temperature and pressure, these are ones that you should have probably memorized. Okay, so the temperature for the Haber process is 450 degrees Celsius, and the pressure is 200 degrees Celsius. So just looking at that, it looks like D is the answer. But let's just double check. Source of nitrogen in the air. Yep, the air is made with a lot of nitrogen. And source of hydrogen, is that from natural gas? Yes, there's a lot of hydrogen in natural gas. A lot more than in the air. Okay, so it's D. Question 32. Which statements about the carbon cycle are correct? Okay, so carbon dioxide is added to the atmosphere by respiration. Yes, you breathe out carbon dioxide because you do respiration. Carbon dioxide is added to the atmosphere by combustion of coal. Yes, that's also true. Carbon dioxide is removed from the atmosphere by photosynthesis. That is also true. So this is 1, 2, and 3. It's all 3 of those are correct. So A. Question 33. Which statement about sulfur and its compounds is not correct? Another one of these not questions. Read them carefully. A. Sulfur dioxide is used as a food preservative. Yes, it is. Sulfur dioxide turns acidified aqueous potassium manganate 7 from purple to colorless. Yes, that's one of the tests you should know. Sulfur forms a basic oxide. Sulfur forms sulfur dioxide, which is acidic. So that looks like a no. And sulfur is used in the manufacture of sulfuric acid. Well, yes, absolutely. So the answer is C. Question 34. Which process is used to convert limestone, which is calcium carbonate, into lime? All right, so you go CaCO3 into CaO. All right. So, is it electrolysis? Nope, I can't see how that would work. Is it fractional distillation? Nope. Nope. Incomplete combustion? No, that wouldn't work either. And thermal decomposition? Yes. It is thermal decomposition. It will decompose. The CO2 will just break off basically, so that when it's heated, so that you're left with CaO, lime. Question 35. What is not, another not question, not the correct use of the fraction named? Okay, so is fuel oil made for making waxes? No, fuel oil should be used for making fuel, I would think. Gas oil, fuel is used for fuel in diesel engines. Yep, that sounds about right. Kerosene, is that a jet fuel? Yep, it is. And naphtha, is that used for making chemicals? Yes, so the answer is A. And another not question. Question 36. Which reaction is not a reaction which alkenes undergo? Bromination. Okay, so remember you have your alkenes. You have C, double bond C, and I'm just going to do ethene. These are H's. Okay, bromination. Yep, you can add a Br2. You can break the double bond and add a Br2. So that one works. Hydration. You can break the double bond and put an H on one side and an OH on the other side. That works. Hydrogenation. You can break the double bond and add an H on one side and another H on the other side. Yes. Hydrolysis. Lysis is to break and hydro is water. No, it's not hydrolysis. D. Question 37. Which substances can be obtained by cracking hydrocarbons? Remember, hydrocarbons are just hydrogen and carbon only. There's nothing else. And when you crack them, you're just breaking it. So ethanol requires an oxygen, which means that both of these are out. They're not possible substances from cracking of hydrocarbons. Okay, now ethene, both of those are fine, same thing, because when you crack a hydrocarbon, you'll always get an alkene. It says it can be obtained. You can get other alkenes that are not ethene, but you can get ethene. Now, which one do you get? Do you get polyethene or do you get hydrogen? Now, polyethene is a polymer, and polymers are very, very long. And when you crack a hydrocarbon, you're making it shorter. So it's not really going to be polyethene. It actually is hydrogen. You can get ethene and you can get hydrogen. You don't have to get hydrogen though. The way that you can get hydrogen, if you're cracking, say, ethene, just put the H's there to be nice and clear. If you're cracking ethane, basically these two H's will come off as H2. So you will end up getting ethene with these H's here plus H2. So that's hydrogen. Okay, so ethene and hydrogen are both possible products from cracking of hydrocarbons. Question 38. Ethanol is produced by fermentation or from ethene. What is a disadvantage of producing ethanol by fermentation? So is it A, distillation is needed to purify the ethanol produced? Well, yes, that makes sense because it's a natural process. They can produce other things in the other waste products in the process of fermentation. Is it, or other options it could be, is it because fermentation uses glucose from plants? Yes, it does use glucose from plants, but that's not a reason why it's a disadvantage. It's a nice, easy source of fuel to make ethanol. Fermentation is catalyzed by enzymes in yeast. It is, but that's not a disadvantage. Again, and fermentation occurs at a low temperature and pressure. Well, that actually is a definite advantage. It's a lot cheaper to do things at low temperatures and pressure than at high temperatures and pressure. So the answer is A. Question 39. Which structural formula represents methyl propanoate? Okay, so remember your methyl propanoate. Methyl, that means that's the alcohol. And propanoate, the OHs, are the acids. Okay, so let's look at this. So we need an alcohol or acid. So with this, I always use my saying, monkeys eat peeled bananas, 1 carbon, 2 carbons, 3 carbons, 4 carbons, methane, ethane, propane, butane. Okay, so methyl, that's 1 carbon for the alcohol, 1 carbon, and propanoate, that's 3 carbons for the acid. All right, so we have these options. There are 3 carbons on one side of the 2 O's and 1 carbon on this one, so that's a possibility. There are 2 carbons on one side and 1, 2, 3 on the other side. That's not a possibility because we need a 1 and a 3. There are 1, 2, 3, 4 carbons on one side and 1 carbon on the other side. Still not a possibility. There's 1 carbon on one side and 3 carbons on the other side. That's a possibility. So now we have to figure out which one of these is the acid and which one's the alcohol. Okay, so now that we have these 2 options, let's draw the first option. Okay, so we have 3 carbons in a row, C, C, C. Okay, I'm just not going to write in all the H's. So the 3 H's on the first carbon, 2 H's on the second carbon, and we have basically 2 O's attached to the next one. The way that the convention is that, just the way that this is written, that there's 1 O attached to one bit there, and the other O is attached to the other bit. That's just the way it works. Now attached to this O, we have another C with 3 H's. Okay, so now when we are creating out, when we are changing it back to the alcohol and the acid, basically we take an H plus an OH, and we break it either here or here. The side that doesn't have an O gets the OH, so both sides will have an OH. So let's break it here. Okay, this side has an O, so it gets an H. This side gets the OH. Okay, so this is an alcohol, and this is the acid. Okay, so this is 3 carbons for the acid, 1 carbon for the alcohol. This means A is the answer. Okay, I'll just quickly draw out the other molecule just so you're clear. So we have 1 carbon on one side with double bond O, an O, and another H. Okay, and then we have our 3 carbons. So we have our C with 2, and a C with 2, and a C with 3. These are all H's. Okay, so that's lots of those. So again, we have our H plus OH. We can break it here. And our H will go to this one. Our OH will go to here. So this one would then be our alcohol. And this one would be our acid. And this would be our alcohol would be propyl methanoate. Propyl methanoate. That would be the name of this molecule. Question 40. Which row describes addition, polymerization, and condensation polymerization? Okay, so addition polymerization, you have to have a double bond so you can add over the double bond. Okay, so it has to have a CC double bond. Okay, condensation means, well, same as with if you look at condensation outside, it means that water has to come out, or something like water. It doesn't. Sometimes it's HCl. So it forms a small. The monomer reacts to form a small the polymer and a small molecule. So this one or this one. So the answer is B. All right, that is the end of this question, and that is the end of this exam. I really hope you found this helpful. If you have, please press the like, and would really appreciate it if you'd subscribe. If you have any comments you'd like to leave for us, please leave them in the discussion below, because we do love to hear from you. And have a great day.